The stereospecificity of nucleophilic substitution reactions of haloalkanes can be exemplified by taking the SN2 reaction of chloromethane with the hydroxide ion, and here the chloromethane, the sp3 hybridized chloromethane, is tetrahedral in shape, and when the hydroxide ion attack this chloromethane, it can approach the chloromethane to the opposite side of the chloride ion attached to the carbon, and therefore first there form a partial bonding with the oxygen of the hydroxide ion with the carbon, and also the leaving chloride ion also have a partial bond with the carbon, and therefore the produced alcohol have an inverted configuration of the parent chloromethane, because the hydroxide ion approach the chloromethane just opposite from the leaving chloride ion. This transition state is not stable and cannot separate from the reaction mixture, and as soon as this transition state formed, the chloride leaved from the transition state and methanol regained. Here the slowest step, both chloromethane and hydroxide, the nucleophile, participate the reaction, and therefore it is a second order kinetics, and therefore the name bimolecular nucleophilic substitution reaction or SN2 reaction. But in case of 2-chloro-2-methyl propane, tertiary butyl chloride, there are bulky methyl groups attached to the carbon to which the chloride is bonded. Therefore, the approach of the nucleophile, the approach of the nucleophilic OH minus ion hindered by the presence of the bulky methyl groups, and therefore there is no formation of a transition state, a unstable transition state, but the first step is the cleavage of CCl bond, tertiary butyl chloride, to form a carbocationic site, tertiary butyl carbocation. And this tertiary butyl carbocation, after leaving the chloride ion, is almost in planar structure, and therefore the approached hydroxide ion, the approaching nucleophile, can attack this carbocationic site from either side of the leaving group, that is through the same side as the chloride is removed, or from the opposite side of the chloride group, and therefore there is a possibility of inversion of configuration and also retention of configuration. Okay, and therefore there is two types of configuration, that is in case of this the OH bond is bonded downwards, and there is another chance as a mirror image of this as the OH minus bonded upwards.